Think about a spaceship that just can't get it right, always having some problem or another. Today, we're looking at Boeing Starliner, a ship that's been having a tough time with issues like computer bugs and leaks. What's going on up there? Stay with us to find out more about this space drama. Boeing never seems to get it right for years. They have been developing the Starliner spacecraft, a project that was supposed to be operational years ago, but they faced constant delays and hurdles, so much so that everyone got frustrated with them and started to believe that the spacecraft would never become fully usable. However, in 2024 they appeared very dedicated to making up for their constant delays by launching a successful crewed mission to the International Space Station. Yet again they faced many problems. They planned to launch the crew multiple times, but issues kept cropping up, forcing them to abort the missions. Most recently they were dealing with a helium leak. After a few days they decided the issue was not serious and they were able to launch the astronauts to the International Space Station despite the problem. But now that same problem seems to have returned to haunt them, and we are going to talk about it in this video. Before delving into the details, please make sure to subscribe to our channel for future updates about this spacecraft and many more. Boeing's Starliner spacecraft has faced many delays and challenges since its inception. The project, which was expected to restore America's ability to launch astronauts into space from US soil, began with high hopes and a significant investment from NASA. In 2014, NASA awarded Boeing a $4.2 billion contract to develop the Starliner as part of its commercial crew program. The goal was to have a reliable spacecraft ready by 2017. The need for a new spacecraft became pressing after the retirement of the Space Shuttle program in 2011. The Space Shuttle had been the backbone of America's human spaceflight capability for 3 decades, but it faced significant safety concerns. The Challenger disaster in 1986 and the Columbia disaster in 2003, where both shuttles were lost along with their crews. With the shuttle program retired, the US faced the uncomfortable reality of relying on Russian Soyuz spacecraft to transport astronauts to the International Space Station. This dependency was not only costly but also politically sensitive. It became clear that America needed to develop its own capability to launch astronauts into space again. In response, NASA initiated the Commercial Crew Program, an ambitious effort to foster public-private partnerships to develop new spacecraft. Alongside Boeing's Starliner, SpaceX's Dragon spacecraft was also developed as part of this initiative. SpaceX's Dragon spacecraft has been remarkably successful. The Dragon successfully completed its first crewed mission, Demo 2, in May 2020. This historic flight marked the first time astronauts launched from US soil since the end of the Space Shuttle program. It has become the most reliable spacecraft for ferrying astronauts to and from the International Space Station, completing multiple crewed missions without significant issues. The success of SpaceX, especially, has made people question Boeing's failure to deliver a similar spacecraft despite receiving almost double the amount of money from NASA. Starliner's first flight to the International Space Station was back in 2019. However, the mission was cut short due to multiple software issues that prevented the spacecraft from reaching the International Space Station. One of the primary issues was a timer anomaly. The spacecraft's mission elapsed timer was incorrectly initialized due to a software error, causing an 11-hour discrepancy. This error prevented the thrusters from firing at the right time to reach the planned orbit, leading the spacecraft to consume more fuel than expected, which ruled out the planned docking with the space station. Additionally, during the mission, a valve mapping error was discovered. This issue affected the thrusters in the vehicle service module, which are responsible for performing a disposal burn after separating from the crew module before re-entry. Had this error not been corrected in time, it could have caused a collision between the service module and the crew module, potentially damaging the capsule's heat shield. A second uncrewed test flight for Boeing's Starliner was initially scheduled for 2020 but faced multiple delays, eventually launching successfully in May 2022. This mission provided the necessary data to move forward with a crewed flight test. However, the path to the crewed test was not smooth. On June 5, 2024, Boeing's Starliner finally launched with NASA astronauts Butch Wilmore and Suni Williams on board. The spacecraft docked at the International Space Station the next day. The mission's primary goal was to conduct a comprehensive on-orbit test of the spacecraft, initially planned to last about a week. However, this mission encountered several issues even before launch. One significant problem was a helium leak in the spacecraft's propulsion system, which was detected during the countdown for a launch attempt on May 6, 2024. Initially, engineers believed the leak was minor enough to permit the launch, but further tests showed it persisted, causing a delay to address the issue. This helium leak was traced to a flange in a thruster within the spacecraft's service module. Engineers attempted to tighten bolts around the leak and performed additional tests to ensure the system retained sufficient performance and redundancy during the flight. Despite these efforts, the helium leak caused multiple delays. The launch was rescheduled several times, finally taking place on June 5, 2024, after NASA and Boeing determined the leak was stable enough not to pose a risk. Even after reaching the space station, Starliner faced additional challenges such as thruster glitches during the docking process, which engineers monitored and addressed. Initially scheduled to return to Earth on June 18, Boeing's Starliner mission faced multiple delays, pushing the return date to June 22, and it may extend even further. One of the main reasons for the delay was the discovery of a helium leak we just talked about. During its time at the station, the crew and engineers continued to address the helium leak and other issues such as a sticky oxidizer valve and faulty thrusters. This extension was also necessary to allow the crew to assist with a scheduled spacewalk on June 13 and to complete additional system checkouts of the spacecraft. The long-term goal for Boeing's Starliner spacecraft is to support 6-month missions docked at the International Space Station. During this extended period, NASA astronauts Butch Wilmore and Suni Williams will perform several critical tests and drills. They will conduct a hot fire test of 7 of the spacecraft's 8 aft thrusters to ensure they are functioning correctly and review hatch operations to guarantee the safe and reliable sealing and unsealing of the spacecraft. Additionally, they will perform safe haven drills, preparing the capsule for potential emergencies by simulating scenarios where the Starliner would serve as a refuge in case of issues aboard the space station. Despite these ambitious plans, Boeing's goal of making the Starliner commercially operational by 2025 appears challenging, given the persistent technical issues the spacecraft has faced. These issues not only delay current missions, but also cast doubt on the spacecraft's readiness for long-term routine use. Moreover, Boeing's choice of rocket launcher has also been a point of contention. The United Launch Alliance's Atlas V rocket, which currently launches the Starliner, is reliable but costly and not as versatile as some newer alternatives. The Atlas V's high cost per launch and its reliance on Russian-made RD-180 engines have raised concerns about its long-term sustainability and geopolitical implications. In contrast, SpaceX's Falcon rockets offer a more cost-effective and flexible solution. The Falcon 9 and Falcon Heavy rockets have demonstrated high reliability and reusability, significantly reducing the cost per launch. SpaceX's ability to rapidly iterate and address issues has set a new standard in the industry, making their rockets an attractive option for future Starliner launches. This shift could enhance Boeing's ability to meet its commercial objectives by 2025, provided they can resolve the technical issues with the Starliner itself. In conclusion, Boeing's journey with the Starliner spacecraft encapsulates the high stakes and challenges inherent in space exploration. Despite the ambitious inception and the backing of NASA with a substantial $4.2 billion contract, the Starliner program has encountered numerous setbacks, from software malfunctions to hardware leaks, which have not only pushed back its timeline but also cast doubts on its reliability and efficiency. These challenges starkly contrast the strides made by competitors like SpaceX, which has rapidly advanced with its Dragon spacecraft, raising questions about Boeing's capability and management in this high-tech arena. As Boeing works to rectify these issues, the path forward is filled with both potential and obstacles. The resolution of the helium leak and other technical problems in the upcoming months is critical not only for the success of the Starliner, but also for maintaining NASA's trust and investment. The long-term goal for Starliner to support extended missions at the International Space Station remains a formidable one, demanding not just technical precision, but also a strategic overhaul of operational practices and quality assurance. The future of Boeing in commercial spaceflight hinges on its ability to meet these challenges head-on and to prove that the Starliner can be a safe, reliable, and cost-effective vehicle for human space transport. This endeavor is not just about recovering from past setbacks, but is pivotal in shaping the future of American space exploration and reasserting its independence in space travel. Thank you for joining us in this comprehensive exploration of Boeing's Starliner project. For ongoing updates on this topic and more insights into the world of aerospace technology, please subscribe to our channel and hit the like button. Your support helps us bring more detailed and timely content straight to you. Until next time, keep looking up, and stay curious about the wonders beyond our world.